Hello everyone. In this video, we are going to learn the fundamentals of chemistry. Okay, let's start. First one, atom. What do you mean by atom? Okay, it is the smallest particle of the matter which does not exist independently. Yes or no? So an atom basically has two main parts. First part is what? A nucleus, and second part is what? Orbit. What do you mean by nucleus? What is nucleus? It is the central part of the atom which contains protons and neutrons. Whereas what is orbit or shell? It is a circular path around the nucleus in which electrons revolve. So basically we can say atom contains three fundamental particles: electrons, protons and neutrons. E for an electron, the charge is negative. What is the value of the charge? Minus 1.6 into 10 to the power minus 19 coulomb. Pa stands for what? A proton. It is a positive charge particle. The value is what? Plus 1.6 into 10 to the power minus 19 coulomb. SI unit of charge is what? Coulomb. N for neutron. Okay, so it is a neutral particle. The value is 0. Okay, it has no charge. So you can see this is a nucleus which contains protons and neutrons, and there is a circular path around the nucleus in which electrons revolve. That is called as orbit. So what is orbit or shell? It is the circular path around the nucleus in which electrons revolve. Okay, so let's see the definition. What is atom? It is the smallest part, okay, or particle of the matter which does not exist independently. Yes or no? What is a molecule? It is a group of atoms which exist independently. Like oxygen is a molecule, chlorine is a molecule, nitrogen is a molecule. Yes or no? Ozone, O3 is a molecule. Okay. Next, we talk about element. What do you mean by element? It is the pure substance which is made up of same kind of atom. Okay, it's like iron, gold, silver, platinum, carbon, nitrogen. So element basically is of four types: metals, non-metals, metalloids and noble gases. Okay, we'll discuss in detail in another videos. Okay, coming to the compound. What is a compound? It is a mixture of two or more elements which are chemically combined together in a definite ratio by mass. Like water. Water is a compound. Ammonia is a compound. Carbon dioxide is a compound. Okay, so how it is a compound we can see also. Okay, like a water example, you see water. So if you take the mass of hydrogen, it is made up of two atoms of hydrogen and one atom of oxygen. Mass of hydrogen by mass of oxygen, you see. Okay, atomic mass of hydrogen is 1, so 2 into 1. Okay, what about the oxygen? Atomic mass of oxygen is 16, so it's 16 into 1. So it is what? 2 by 16. 2 1 ja, 2 8 ja. So ratio of masses of hydrogen to the oxygen is always 1:8. Okay, like that other compounds are also. Okay, so next we talk about elements, their symbols. Okay, very important. Symbols are what? How elements are represented. Okay, so I have written a few elements with their symbols. Like hydrogen, symbol is capital H. Helium, capital H, small e. So generally symbols is what? First letter, okay, of the element, or first two letters, or first letter, or in between some letter will be there. Yes or no? Like lithium, capital L, small I. Beryllium, Be. Boron, just B. Carbon, capital C. Nitrogen, N. Oxygen, O. These are the symbols. Okay. Fluorine, F. Neon, capital N, small e. Gold. Okay, some elements are written, their symbols are written with their Latin names only, with the help of Latin names only. Like gold, Latin name is aurum, so the symbol is Au. Similarly, mercury, hydragyrum, so Hg is the symbol. So now, next, sodium, Latin name of sodium is what? Natrium. Okay, so Na. Okay, Na. Next, magnesium, Mg. Aluminium, Al. Silicon, Si. Phosphorus, just P. Sulfur, S. Chlorine, Cl. Argon, Ar. Okay, potassium, Latin name of potassium is what? Kalium, so just K. Calcium, Ca. Okay, iron, ferrum is the Latin name, so Fe. Silver, argentum is the Latin name, so Ag. Yes or no? Okay, let's discuss some more concepts like atomic number, mass number, isotopes, isobars. When we talk about atomic number, it is defined as what? The number of protons present inside the nucleus of the atom. Okay, so generally it is denoted by capital Z. Okay, so Z is nothing but a number of protons which is present inside the nucleus of an atom. Okay, or we can say it is the number of electrons present outside the nucleus of a neutral atom. Okay, so Z is also equal to number of electron, but this is for neutral atom only. Yes or no? Because electrons number can be changed. Electron can be lost by the atom or gained by the atom. Yes or no? So for a neutral atom, how many electrons are there? So that is the atomic number we can say. So finally we can write that for a neutral atom Z here, that is atomic number is equal to the number of protons or number of electrons. Okay, you can see the definition. It is defined as the number of protons present inside the nucleus of an atom. Whereas also we can other definition is that it is defined as the number of electrons present outside the nucleus of a neutral atom. It is denoted by capital Z. Let's talk about the mass number. When we talk about mass number, it is the sum of protons and neutrons present inside the nucleus of an atom, and it is denoted by capital A. Okay, so how we can write the mass number? That is capital A is equal to protons plus neutron, which is present inside the nucleus of an atom. Yes or no? Okay, generally for any atom X, atomic number we are writing at the bottom left, and mass number, okay, top left. Okay, right side also some books are writing. Okay, so you can see here like carbon, C is the atom, atomic number is 6 and mass number is 12. Nitrogen, atomic number is 7, mass number is 14. Okay, so what is Z? Z is the atomic number and A is the mass number. Okay, some books are writing like this 6, 12 also. This is the mass number, this is the atomic number. One important question they are asking in the exam to find the number of neutrons. Okay, to understand this, just see here what is my mass number A, that is equal to P plus N, yes or no? And what is atomic number? Atomic number is nothing but a number of protons. Number of protons is atomic number. Subtract mass number minus atomic number. So A minus Z if you do, so P plus N minus P plus P minus P, yes or no? So P get cancelled, so you get the number of neutron is equal to A minus Z. It means to find the number of neutrons we have to, okay, subtract the mass number. Okay, we have to subtract the mass number from, sorry, we have to subtract the atomic number from mass number, yes or no? So mass number minus atomic number will give you the number of neutrons, yes or no? For example, you can see here carbon is there. Okay, atomic number is 6, mass number is 12. So as atomic number is 6, so Z is 6. So number of proton is also 6 only. Okay, neutral atom, so electron is also 6 only. What about the mass number? Mass number is 12. How many number of neutrons are there? So 12 minus 6, that is mass number minus atomic number. 12 minus 6 is how much? 6 only. Like that, questions will be asked in the exam, okay, to find the atomic number. Let's talk about the electronic configuration. It's very important. With the help of electronic configuration only, we are finding the valencies of the atom. Yes or no? We are able to tell whether the atom is metals, non-metals, or noble gas. Yes or no? So let's start electronic configuration. Okay, as the name suggests, electronic related to the electrons only, and configuration means arrangement. So we can say it is defined as the arrangement of electrons in the atom. Yes or no? So it is following one rule called as 2n square rule. What is this rule? Okay, this rule states that the maximum number of electrons which can be present in a shell is given by 2n square. Okay, this was given by Bohr only. Okay, he told that for n is equal, you can see as I told you that atom is there which contains nucleus and electrons are revolving in the circular path, that is called as shell or orbit. So Bohr, this was given by Bohr. So what he had told, for n is equal to 1, it is called as K shell. The name is what? K shell. Okay, how many electrons is there? 2n square. So 2 into n value is what? 1. So 2 into 1 square. 2 into 1, that is equal to 2 electrons. Yes or no? Similarly, you can see n is equal to 2, that is L cell. 2 into 2 square is the maximum number of electrons which can be present. So 2 into 2 square is what? 2 into 4, 8 electrons. Similarly, n is equal to 3, that is M shell. 2 into 3 square, that is 2 into 9, 18 electrons. Yes or no? Similarly, n is equal to 4, N shell. 2 into 4 square, that is 2 into 16, 32 electrons can be there. Should also remember, while doing the electronic configuration, if the valence electron is 8, we will give. More than 8 we cannot give, like 9, 10 we cannot give. Either 8 or 18. Okay. So let's discuss some more concepts like isotopes. What is by isotopes? These are the atoms of same element having same atomic number but different mass number. For example, hydrogen is having three isotopes: H11, H12, H13. This is called as protium. H12 is called as deuterium, and this is called as tritium. Okay. Similarly, carbon has isotopes: carbon 612, 630, 640. These atomic numbers are same but mass numbers are different. You can see the different definition. These are the atoms of same elements having same atomic number but different mass number. As the mass number is different, so number of neutrons will be also different also. In MCQ, they may ask you find the number of neutrons in deuterium. So 2 minus 1, 1. Protium, 1 minus 1, 0. Yes or no? Now, what is my isobars? Okay, what is isobar? It is a isobars are the atoms of different element having same mass number but different atomic number. Yes or no? So we can see like argon, potassium, and calcium. Atomic numbers are 18, 19, and 20. Mass numbers are 40, 40, and 40. Yes or no? In the exam, they may also ask you about the uses of isotopes. You should know some uses like isotopes of uranium. Okay, isotopes of uranium. Okay, 92 to 235. It is used as a nuclear fuel. Where we are using it is used as a nuclear fuel. Okay, isotopes of cobalt isotopes of CO is used for the treatment of cancer. Is used for the cancer treatment. Isotopes of iodine is used to treat a disease called as goiter. What happens in goiter? This thyroid gland is enlarged. Okay. Similarly, we can say isotopes of carbon. Okay, isotopes of carbon is used for carbon dating. Okay, to know the ages of the fuels, fossil fuels. Okay, fossil fuels ages. So these are the few uses of isotopes of various elements. Okay, one more concept is there called as isotones. What do you mean by isotones? When we talk about iso means same, tones means neutrons. Tones stands for neutrons. So these are the atoms of different elements having same number of neutrons. Same number of neutrons. Okay, so for example, you can see oxygen 8 and 16. What is the number of neutrons? 16 minus 8, that is 8. In case of nitrogen, 7 and 15. How many neutrons are there? Mass number minus atomic number, that is 15 minus 7, 8. So these are the atoms of different element having same number of neutrons. Yes or no? So let's come back to the electronic configuration only. I have done electronic configuration of few important elements which you should know, like sodium. Serial number 1, sodium. Atomic number of sodium is what? 11. Okay. Here this side electronic configuration is there. Where I have written cell, K shell, L shell, M shell, N shell. So the rule says first shell will have 2 electrons right now. Next 8 electrons. So 2 plus 8 10. So total 11 electrons were there. So 11 minus 10, how much? 1. So 1 is the electron present in the third shell. Yes or no? Here only just now we discussed now. The first cell can have how many electrons? 2 electrons. Okay. Second cell can have maximum 8 electrons. Third cell 18. Fourth cell 32. So this is according to the 2n square rule. Okay. Similarly, magnesium you see. Atomic number is 12. Electronic configuration 2, 8, 2. Yes or no? Aluminium you see. Atomic number is 13. So 2, 8, 3. Remember one thing, if the valence electron, what do you mean by valence electron? The electron present in the last cell is called as what? Valence electron or valence cell electron. If the valence cell electron is 1, 2, 3, generally they belong to metals. And their valences are nothing but valence electron, 1, 2, and 3 respectively. Yes or no? Now let's see. Oxygen, atomic number of oxygen is 8. Electronic configuration, first shell 2 electrons, next 6. Okay. Nitrogen, atomic number is 7, so 2, 5. So no. Fluorine, atomic number is 9, so 2, 7. So no. Chlorine, 17 is the atomic number, so 2, 8, 7. So 2 plus 8, 10, 10 plus 7, 17. Yes or no? 17 electrons are filling. Sulfur, 16. So first cell we can give 2 according to the rule. Second cell 8, next cell 6. 2 plus 8, 10, 10 plus 6, 16. Yes or no? Remember one thing, if the valence electron is 4 or more than 4, like 4, 5, 6 or 7, generally they belong to non-metals. Generally they belong to non-metals and their valencies are 8 minus valence electron. In case of oxygen, what is the valency? 8 minus 6, that is 2. In case of nitrogen, okay, nitrogen 5 is the valence electron, so 8 minus 5, that is 3. Fluorine 7 is the valence electron, so 8 minus 7, that is 1. Okay, chlorine also very very important. Valence electron is 7, so 8 minus 7, that is equal to 1. Yes or no? Let's talk about potassium and calcium also. Potassium atomic number is 19. Electronic configuration first shell 2, next 8, next we cannot give a 9. See 2 plus 8, 10 only. Yes or no? So 19 is there. So 10 is already filled. How many remaining are 9? We cannot give 9 electron to the third shell. The rule says either it will have 8, 18 is there. First we will check for 18. If 18 is not there, then we can give 8 only. Okay, that is the next stable. So 2 plus 8, 10, 10 plus 8, 18, then 1 electron go to the N cell, that is fourth cell. So no? Similarly for calcium also, first shell 2, then 8, then 8, then 2. So 2 plus 8, 10 is there, 10 plus 8, 18, 18 plus 2, 20. So valence electron you can see 1 and 2 is there, so respectively they are metals only, and valence electrons are 1, 2 means valence is also 1 and 2 only. Now we focus on this neon argon. Neon atomic number is what? 10. So electronic configuration 2, 8. Okay. Similarly argon 18 is there, so 2, 8, 8. If the valence electron is 8, generally it belongs to noble gas or inert gas we can say. So it is having a stable configuration. So the valence is 8 minus 8, that is equal to 0. Okay. Helium is the exception. Helium atomic number is 2. Okay, so it has 2 electrons in the valence shell only, first shell. So valence is 0 only. So these are also called as noble gas. What they are called as? Noble gas or inert gas. Inert gas. So if you know the valencies of various elements, symbols of various elements, then you can write the chemical formula, correct chemical formula, which is very very important. So we are going to learn how to write the chemical formula. Okay. So first crisscross method. Okay, aluminum chloride you see. First of all we are writing the symbols. Aluminum symbol is Al, chloride stands for chlorine actually, right now Cl. Below we are writing the valency. Aluminum valency is 3, chlorine valency is 1. Now crisscross method. 1 will move here and 3 will move here. Okay, so AlCl3 is the chemical formula for aluminum chloride. Similarly, sodium oxide. Symbol is sodium Na, oxide O. So now valency of sodium 1, oxygen 2. So crisscross method you can do. 1 will move here, 2 will move here. Okay, so Na2O. 1 generally we are not writing. So Na2O. Okay, fine. Let's talk about the magnesium oxide. Magnesium Mg, oxide O. Valency is 2 and valency is also 2 only. Yes or no? So if the valencies are same, we can cancel also. 2 1 2 1. So 1 will move here. 1 we are generally not writing. So MgO. Similarly, hydrogen sulfide. Hydrogen H, valency is 1. Sulfur, sulfide is what? Sulfur, valency is 2. So crisscross method. 2 moves here, 1 moves here. So H2S. Yes or no? You should also remember some cations or anions we can say, radicals are there. Okay, cations are the positively charged atoms. Okay, or anions are what? Negatively charged atoms. Radicals are what? A group of atoms may be there. Okay, like carbonate CO3 2 minus, sulfate SO4 2 minus. So here I have made some list okay, of cations or anions. Okay, that is positive radicals are called as cations, like hydrogen H plus 1. Valency generally 1 or plus 1 we can say. Sodium Na plus 1, valency is 1. Okay, potassium K plus 1, calcium Ca2 plus. Okay, magnesium Mg2 plus, aluminum Al3 plus. Okay, ammonium NH4 plus, copper Cu2 plus, ferrous Fe2 plus, ferric is Fe3 plus. Okay, na? And some negative radicals which are anions. Okay, which is very very important. You should remember chloride Cl minus, hydroxide OH minus. Okay, nitrate NO3 minus, sulfate SO4 2 minus, carbonate CO3 2 minus, bicarbonate HCO3 minus 1, phosphate PO4 2 minus, acetate CS3 COO minus, sulfide S2 minus. Okay, now let's learn some more chemical formula like a calcium carbonate. Okay, let me explain calcium carbonate. Okay, so calcium first we are writing Ca. It is a positive radical, so Ca 2 plus, carbonate CO3 2 minus. If it is same, we can cancel, plus 2 minus 2 get cancelled. So 1 1 we are getting right now. So Ca1 CO3. So directly we are getting CaCO3. It is calcium carbonate. The marble formula is this only, limestone formula this only. Okay, so calcium carbonate. Next, iron sulfate. Let's talk about the iron sulfate. Iron is what? Fe 2 plus, sulfate SO4 2 minus. Again 2 plus 2 minus 2 get cancelled. So we are getting FeSO4. Is it clear? Next, we talk about the magnesium hydroxide. Let's see. Done. Magnesium is what? Mg 2 plus, hydroxide OH minus 1. So 2 will move here and 1 will come here, right? So whenever 2 is coming, it will go with O atom and H atom both. So we are taking Mg1, okay, OH in bracket you should write twice. Is it clear? Similarly, we can talk about the sodium nitrate. Okay, let's talk about sodium nitrate. Na 1 plus or plus 1 and NO3 minus 1. Okay, now yes or no? So Na NO3 1 plus minus 1. So Na NO3 is the sodium nitrate. Yes or no? Similarly, we can see copper sulfate Cu 2 plus SO4 2 minus. So CuSO4. Okay, sodium bicarbonate Na plus 1 bicarbonate HCO3 minus 1. So Na HCO3. Ammonium hydroxide ammonium NH4 plus 1 hydroxide OH minus 1 right now. So we can write NH4OH. Okay, one generally we are not writing. Potassium carbonate potassium K plus 1 carbonate CO3 2 minus. So 2 will move here and 1 will come here right now. So K2CO3 K2CO3. Sodium carbonate Na plus 1 CO3 2 minus. So 2 will move here right now, 1 will come here. This one, so Na2CO3 important this one. Calcium sulfate Ca2 plus SO4 2 minus. Plus 2 minus 2 get cancelled, so CaSO4. Bleaching powder formula. Some more important formulas are there which is there for grade 10. You should remember. Bleaching powder is what? Calcium oxychloride CaOCl2. Plaster of Paris, calcium sulfate hemihydrate. So CaSO4 and half H2O. Hemi means what? Half. Okay, so water of crystallization is there, half. Okay, washing soda Na2CO3 dot 10 H2O. Here 10 water molecules is attached. Okay, so 10 water of crystallization is there. So sodium carbonate decahydrate. 10 means what? Deca. So decahydrate. Apart from these, you should also know some important acids. Okay, names, important salts names. Like sulfuric acid H2SO4. Okay, you must remember because it is frequently used in the chemical equations. Hydrochloric acid HCl. Phosphoric acid H3PO4. Nitric acid HNO3. Magnesium hydroxide MgOH twice. Aluminum hydroxide AlOH thrice. Okay, 3 is there, Al3 plus OH minus 1. So 3 will move here. So within bracket with OH we can write AlOH thrice. Common salt is what? NaCl. Okay, sodium chloride. Rust formula. What is the formula for rust? Fe2O3 dot XH2O. It is called as hydrated ferric oxide. Quicklime CaO, calcium oxide is called as quicklime. Select lime, calcium hydroxide. Okay, CaOH twice. Okay, so you can see valency is very important. What is valency? It is the combining capacity of an atom. Yes or no? So it is obtained from the electronic configuration only. What is the point I told you? If the valence electron of the atom, okay, that is the outermost shell electron is what? 1, 2, 3. Generally it belongs to metal and valency is what? 1, 2, 3 respectively. You can glance over these points. And if the valence electron is 4, 5, 6 or 7, generally it belongs to non-metal. And valency is what? 8 minus valence electron. So, no? And last point, if the valence electron of the atom is 8, generally it belongs to the noble gas or inert gas and its valency is 0. Okay, so this is all about the fundamentals of chemistry. I hope you understood these concepts. You have to practice once. If you like this video, please share with your friends and don't forget to subscribe the channel. Thank you.